Well, good afternoon, ladies and gentlemen, and welcome back to CIGRE Chat. We are here with Greg Elkins from Global Power Energy. How are you, Greg?
Oh, doing very well, thank you.
Doing well. I heard last night on the grapevine that you were out to 2 a.m. in the morning.
Oh, I can neither confirm nor deny.
Confirm or not deny.
That doesn't sound a lot like me.
It doesn't sound like you at all. Oh, well, you're looking good for a heavy night out on the tools, which is great to see. Mate, we're here today. We're going to chat a little bit about yourself, a little bit about Global Power Energy. But I want to start off by talking about Adam Middleton. Now, he was one of our guest speakers here, and he was talking about the industrialisation of energy transition. And how do we accelerate the transition through effective communication and process understanding?
Well, I think it's key for us is to understand, where we are, where we're going, and to help people, see, the why of the power system and the why the process is developed, and the decision with respect to performance criteria is there for the protection of a safe, secure, reliable power system. And understanding the why of those things helps us, move things forward. What I also found really interesting what Adam said is in relation to the standardisation. And he was saying that we can't just go and do a bespoke assessment every single time. And so when we look at wind farms, we're actually looking at a 2 gigawatt wind farm and breaking it up into 8 by 250 megawatt blocks. So it's cookie cutter, so that we can apply our appropriate engineering margins and progress forward more efficiently.
So if I'm getting this right, you're basically saying instead of this person building this wind farm and this one building this wind farm, we get it like a standard, yep. And then just everyone follows that standard. Is that
that's right? And so we're talking with network service providers as well about how do we roll this out, not just within one state, but across multiple states, so that you can also reduce your risk with respect to contingencies. If you've got a bespoke transformer every single time, you've got one large credible contingency. But if we buy 10 transformers that are exactly the same, we can buy one spare and cover the risk across 10 sites.
So how do you do it? Like you talked about state by state. So we're talking within Australia here you're talking about, or is this more globally?
So with the customers we're talking with, they're actually looking at the standardisation across the fleet as well. However, many jurisdictions have evolved differently through the power system, and you have voltage levels across different global jurisdictions as well. But one of our main customers, RWE, they're looking at standardisation across our whole European fleet as well.
Right. So if we're to get these standardisations in place, and there's a lot of technical talk in relation to building these infrastructures, how do we turn that technical communication into something that's understandable for senior management to go, okay, yeah, that makes sense to me. Let's go ahead with that.
What you got to do is you got to go back to that why again. You got to understand the why so that you can actually explain it in simple terms, so that the person can have a tailored solution to the way they understand things. Working with illustrations, working at different mechanisms, understanding that it's not going to be exactly 100% technically correct, but it's about conveying the message, because in the end the decision makers need to be able to make an informed decision with respect to the risk that's presented to them. And so it's not about absolutes, it's about looking at the risk and the probabilities to determine the right pathway forward.
So you've got a barrier either side. You're aiming for the middle, but you're giving yourself a little bit of leeway.
Absolutely, and I think that's probably one of the biggest challenges as engineers is we like things to be right, we like things to be correct, but how do we then apply an engineering margin? And with respect to some of the really technical things, and when you go from a linear to a non-linear arrangement, the definition or the arrangement of engineering margin might not always be the same. And so for one technical parameter, you might need to put a greater buffer, where for the next technical parameter, you need to do the opposite. For example, you might increase the impedance to cover off one risk and reduce the impedance to evaluate a secondary risk.
Right, okay, that makes sense. So how do you empower people to take that leap?
So the power of decision making is really important, because if you can't make decisions and you're not giving people the capacity to make a decision and sometimes make a mistake, you're not going to be able to move things forward. And we get stuck in the paradigm of analysis paralysis, which is really dangerous for any transition or any rapid moving progress. So at Global Power Energy, our mission is to deliver rapid success in the energy transition, and we can't do that if we can't make decisions. So it actually requires managers and senior leaders to actually acknowledge that as we move forward, not everything is going to be perfect every single time. And if we analyse forever, we're going to spend a lot of money and cost in that analysis, but we may not get the right outcome in the end anyway, because we don't know all the different decisions and all the different probabilities that could occur.
Okay, you just spoke about costs,
Yep.
about that. So how do you balance out the balance between investigating the science and how this is done and the economics behind it? How do you balance that out?
What you've got to do is you've got to have a look at what your engineering margin is, so that you can see, with respect to your economic investment, it's about risk, it's about value, and it's also about the certainty. So in order to have the certainty that I won't be curtailed on my generation into the future, I may over-invest in a particular technology, synchronous condensers, harmonic filters, so that I can have the awareness or the confidence that I'm going to oversupply the requirements that I'm meant to have. And the way I look at it is, engineering is meant to be that perfect balance between science and economics, taking into fact what we know about the world, but then also taking into the fact that we have to be able to invest it in order to move things forward.
Excellent. Greg, is there any other messages you want to pass on to the delegates here from Global Power Energy?
What I think we want to be able to do is we want to be able to drive this transition forward. We need to be able to take well-informed risks and understand that not everything is 100% absolute, and to be able to move things forward. And we've got a big job ahead of us. Let's just get on and do it.
Let's go and do it. I like it. Get on and do it. Get it going. Get it done.
Absolutely.
Greg, thank you very much for your time, sir.
All the best.
Ladies and gentlemen, please put your hands together for Greg from Global Power Energy. We'll be back later on, well actually tomorrow, with some more CIGRE chat. We'll see you then.